Okay, so this is one topic that has shown up on your homework this week, and I'll just say these problems usually end up being, I think, a lot more intimidating than they actually are, because you just see a lot of numbers thrown at you, a lot of equations thrown at you at once, and it can seem very intimidating for what to do. But like every math problem, if you break it into smaller pieces, these really are not bad at all, and this is especially true of these things called piecewise defined functions. Okay, a piecewise defined function is exactly what it sounds like. It's defined in pieces. Okay, it doesn't have to necessarily be continuous, and it can have different functions defined for it, or different equations defined for it, different expressions defined for it for different parts of the number line. Okay, so here's an example. This first one is an example of a function that is definitely not continuous, and it spits out numbers depending on different numbers that you put in. Okay, so really what we're doing here is we're checking what the input is, and then we're going to evaluate it for the appropriate output. Okay, so here we have h of x is -2 if your input x is between -2.5 not included, and then -1.5 included. Okay, we have -1 if x is between -1.5 not included and -0.5 included. It's 0 if it's strictly between -0.5 and 0.5, and it's 1 if it's between 0.5 included and 1.5. Okay, and so all you have to do is check where these inputs are and then evaluate it at that point. So first, let's check h of -1.5. Okay, so h of -1.5. We know 1.5. Let's just check over here and see which of these intervals that it falls into. -1.5 is going to fall in this interval, and the reason is because this interval is from -2.5 to -1.5 included, meaning we're including the point -1.5. Okay, and so we also know that h of x is -2 if it's in that interval. So we just know that h of -1.5 is -2. Okay, next we have h of -0.5. Okay, this is very similar. So let's check here. We know it's not in the first one, so -1.5 to -0.5 included. So it must be that one because it lies in this interval here. Okay, therefore it must be -1. Okay, because this is your output for that interval. If we check h of 0.5, okay, h of 0.5, well, let's check here. We know it's not in the previous one. We know it's not in -0.5 to 0.5 not included because we're not including the point 0.5. So it must be in this last one here. We have 0.5 included, good, to 1.5. So it's in this one. Okay, and so what we do is we go ahead and say that it's 1 because this is your output here. Okay, and then for h of 1, again, you just check to see what the interval is. H of 1 is going to fall into the same interval we had here. So h of 1 is equal to 1. All right, so again, they seem very complicated, but in reality, these are quite simple. Sometimes the hardest work here is just checking what the interval is that your input falls into. Let's do one more example though, just for good measure. Let's say g of x is equal to -3 if x is strictly less than -2. It's equal to negative x plus 1 quantity squared plus 2 if x is less than or equal to -2 but less than 2. And it's equal to 1/4 x plus 2 if x is greater than or equal to 2. Okay, so let's go ahead and check g of -1. So g of -1, so -1, it's not less than -2, but it is in the interval from -2 to 2. Okay, so -1 does fall here. So this is going to be where we're going to be looking here. So g of -1 means we're going to evaluate -1 using this expression here. Okay, so we'll have -1 plus 1 squared plus 2. Okay, so this is going to be negative. All right, so -1 plus 1, that is going to be 0. So -0 squared plus 2, or just 2. So g of -1 is going to be equal to 2. Okay, so we're just using this output here to evaluate our our uh, our function at that point. Let's try g of 2. Okay, g of 2. Obviously, it's not in this top interval here. It's not in this one either, we just used, because we're not including the point 2. But if x is greater than or equal to 2, we're going to evaluate it at 1/4 x plus 2. So we're going to evaluate this as 1/4 times 2 plus 2. Or we have 1/2 plus 2, or this is the same thing as 1/2 plus 4/2, so we get 5/2. Okay, and then lastly, g of 5. Okay, g of 5, again, it falls in the same interval we did last time, so we get 1/4 times 5 plus 2, which is the same thing as 5/4 plus, we said, okay, so 2 is the same thing as 8/4. So 8 plus 5, that's 13/4. Okay, so there we go. So this is how you define and evaluate piecewise functions. I promise they're not too bad if you just take the time to check what intervals they're in. Most of the outputs they're going to give you are not too terrible. So mostly stuff you've seen before. So yeah, if you have any questions at all with this one though, feel free to reach out, send me an email, and I can try to make more specific videos if you run across something that's a little more complicated than this. I'm fine with that. But yeah, I would just encourage you to try to break it down as much as possible before you panic when you see one of these. So good luck and have a good one.